and welcome to another physics problem. Today we're going to solve another problem of physics which has come in JEE Mains 2022. It is also coincidentally a numerical integer value type problem. It is a very short one, so let's first read the problem. I hope it is in front of you. Equivalent capacitance between points A and B in the below shown figure will be dash microfarads. So let's draw the figure. Now there are two things which I can see in the figure. Number one is we have been given two nodes or two endpoints across which we want to find the equivalent capacitor, that is A and B. Number two, all of the capacitors have the capacitance 8 microfarads. So let's draw the figure. Okay, so this is a point A, and I'm going to have a circuit. I'm going to quickly draw the circuit. We've got two capacitors over here. We've got a connection which, okay, I did a bit wrong, so this is not there, and we have a capacitor here as well, and this makes a connection over here, and we have these two capacitors, and we have one more capacitor over here, and this is our second node or endpoint B. And let's represent each of these by C, and we are aware of the fact that C is 8 microfarads. So what you want to find here is the equivalent capacitance. Now, none of these capacitors can be directly seen connected in series or parallel. So we will have to use the potential dot method to find the equivalent capacitance of this circuit. So we're going to write the potential at each of these nodes, and I'm going to draw the simplified equivalent circuit. So this point will have, okay, I think it's visible. So this point will have a potential of A. This point shall have a potential of A, and each of these points will have potentials of A. All right, and this point will have a potential of, let's say, okay, this point will have a potential of X, and this X will continue everywhere. So there we go. Now there's one more thing you want to look over here, is that these two capacitors are connected between same potential differences. So what happens is that these two capacitors at the end get sorted, or no current flows through this capacitor any time between the circuit, so they will not have any charge, and since they do not have any charge, the capacitance, that is Q by V, becomes 0. So we're not considering the capacitance due to these two capacitors. So we need to draw the equivalent circuit. So now we have X, A and B as 3 points. So let's draw the equivalent circuit. So A, B, and we've got another point over here, X. Now what you want to note here is that when you draw the equivalent circuit, you always should have A and B at the two terminals, because we're finding the equivalent capacitance across A and B. Alright, so we have A, X, and 3 capacitors are connected between A and X. This is one of them, this is the second, and this is the third. So we will have 3 capacitors like this. Alright, so this, and we'll have another capacitor. So these are 3 capacitors connected like that. And we'll have just a single capacitor. Okay, there's one more. Okay, so these 2 capacitors are sorted. So we will have just one more capacitor between X and B. Now you can now see that it's a very simplified circuit. You find the potential across capacitance across these 2 points. So these 3, now, each of them have a capacitance of C. So 3 of them are in parallel. So if we simplify the circuit furthermore, what we get is a series of 2 capacitors connected in series. Now this capacitor is this one, so I refer to this one. So this is C, and these 3 capacitors are connected in parallel, so their equivalent capacitance will be 3C. I hope it's very clear. So in this circuit, the C equivalent should be, in the general formula for series, is C1 by C2 by C1 plus C2. So if you apply that over here, so what we get is 3C times C, this is times, and divided by 3C plus C. And so if we solve this, we get 3 by 4C. So in this circuit, the equivalent capacitance is 3 by 4 C, and C is 8 microfarads, you can see over here. So what we get is 6 microfarads, and this is the required answer. Thanks a lot for watching.